Hello students, in today's session, we are going to discuss the position of the center of mass. In the last class, we have seen what is center of mass and what are the characteristics of the center of mass. So let us continue the same, that is the position of the center of mass. When we are speaking about the position of the center of mass, we have to discuss the three cases. The first one is one dimension, two dimension, as well as three dimension. So let us start with one dimension. How to calculate the position of the center of mass in one dimension. Then we move for the two dimensions, and at last we are going to discuss about the three dimension. So we start with one dimension. So position of the center of mass in one dimension. So I'll go with this one. One dimension. One dimension means 1D. Now, for this, what I consider, pay attention, this is very important. And if you understand, this will be very easy also. So if I take this as an x-axis and this is the y-axis. So here we are finding the position of the center of mass, or in short, I say the coordinates of the center of mass in one dimension. So for that, I am considering just two particles. You may consider any number of particles. There is no restriction for the number of particles. So here, what I do here is I consider a particle of mass m1. It is at a distance of x1 from the origin. x1, try to understand, a particle of mass m1 is kept at a distance of x1. Next, another particle, I consider it of mass m2, and this is at a distance of x2 from the origin. Now, where is the center of mass? The center of mass always lies in between these 2 points, that is this point as well as this point. So where is the center of mass? We don't know. Suppose I consider the center of mass, position of the center of mass is this one. And how much is this distance from the origin? I consider from here to here, that is xcm. This is xcm I am considering. I repeat once again, here we are considering only two particles, students. It's not necessary, there is no restriction, I can say, for the consideration of number of particles. I have considered just two masses to make the concept easy. Now, if I want to write the position of this center of mass, that is coordinates of the center of mass, or in short, position of the center of mass in 1D, so how to write this? This is xcm is equals to m1 x1 plus m2 x2 by m1 plus m2. So this is the formula or the concept by which we can calculate the position of the center of mass in 1D. So this is xcm, and this is the distance I am getting from the origin. Once more time, here if you consider three particles, यहाँ पे देखिए very important thing, if suppose you consider three particles. So if you consider three particles, like you can consider here m3 at a distance of x3, then the formula will extend or modified to m1 x1 plus m2 x2 plus m3 x3. You need to add one more term, right? Divided by m1 plus m2 plus m3. I hope you have understood this. Now this is about what I can say one dimension. Now let us go for the two dimension. So two dimension means we need to consider x-axis as well as y-axis. Two dimensions, one x, other y. So let us move with that. It's also very simple if you understand. See here, I'm going for the second part. Two dimensions. Now for this, what I consider, this is x-axis, this is y-axis, and this is what? Origin. I take here in the xy plane, if I take a particle of mass m1, and its coordinates are x1 comma y1. Try to understand. Here I have kept the particles on the x-axis, only a single line. That's why I'm considering it as 1D, one dimension. Here where I am keeping the particle, I'm not keeping on the x-axis, I'm not keeping on the y-axis. Where I am keeping the particle? In a plane, xy plane में कहीं पे भी एक जगह रख दिया मैं. So where I am keeping this particle of mass m1, I am keeping at x1 comma y1. That is one of the point what I am mentioning, where the mass m1 is kept. I hope it is clear. Now I take another particle somewhere here, कहीं पे भी एक जगह ले लेंगे हम. This is m2, and the point is x2 comma y2. Now, where is the center of mass? 100% the center of mass will be lying in between these two masses. दोनों masses के बीच में ही center of mass होता है. इसके बाहर नहीं होगा बेटा, इसके बाहर नहीं होगा. The center of mass lies along the line joining these two masses and in between the masses. So how to calculate the position of the center of mass? So here we need to calculate x coordinate as well as y coordinate. X coordinate, how to calculate? Already we have seen how to calculate the x coordinate. This is the concept what we need to here use. If I take m1 x1, m2 x2 by m1 plus m2, this is the x coordinate of the center of mass. Similarly, I can calculate y coordinate of the center of mass. So it is m1 y1, m2 y2 by m1 plus m2. Now I want to go for to specify the position of the center of mass. So center of mass, in center of mass, how to specify this? This is xcm comma ycm. Means after getting the result of this and this, suppose इसको हम solve करें and I am getting answer as 2. इसको solve करता हूं बेटा, आंसर आता है 3. Then the center of mass will be 2, 3. 2, 3. That is in the point wise. So I hope you have understood this 2 dimension also. Let us move for the 3 dimension. 3 dimension means you have to consider x axis, y axis as well as z axis. It's very simple because you have understood this. You have understood this, that the third part will be very easier for you. Now I'll go for the 3 dimension now. For this 3 dimension, what I consider, this is x axis, this is y axis, and another axis I am considering, that is z axis. And of course, this is the origin. Now in space, I'm not speaking about one dimension, that is a line. I'm not speaking about what I can say one plane, that is 2 dimension. Anywhere in space, if I keep a particle of mass m1, anywhere, kahin bhi rakh dijiye. I'm taking an example here. So it is m1 and the coordinates are x1 comma y1 comma z1, x1 y1 z1, because 3D हम डिस्कस कर रहे हैं. और एक कोई भी एक पार्टिकल ले लीजिए बेटा, कहीं भी एक पार्टिकल ले लीजिए, एनीवेयर, यहाँ पे कहीं भी ले लीजिए. सो इट इज m2 I am considering, x2 y2 and z2. I need to calculate the position of the center of mass under this situation where I am considering 3 dimension. So for this, what I have to take here is axiom is m1 x1 plus m2 x2 by m1 plus m2. YCM m1 y1 m2 y2 by m1 plus m2, and ZCM m1 z1 m2 z2 by m1 plus m2. After getting this, we can write the center of mass as xcm comma ycm comma zcm. Hope you have understood when we consider about the 1 dimension, 2 dimension and 3 dimension. So students, we have seen how to calculate the position of the center of mass in 1 dimension, 2 dimension and 3 dimension. Let us take few problems as an example for this concept. The first problem on the board, you can see here, the first problem you can see clearly, 2 bodies of masses 1 kg and 2 kg. 1 kg and 2 kg are there, are lying in the xy plane at the points -1, 2 and 3, 2, 4 respectively. What are the coordinates of the center of mass? You can clearly see the question speaks about the 2 dimension. The reason here is they have mentioned as the point wise, x coordinate as well as y coordinates both are given. So let us start how to do or how to move with this problem. So here what I consider, I'll write first the given data. M1 is equals to 1 kg, M2 is equals to 2 kg. That is given. This is 2 kg. 2 kg. Now the points they have mentioned it as -1, 2. This is for the particle of mass m1. Another particle is kept at 2, 4. So what I consider here, it is x1 and y1. This is x1 y1 and this is x2 y2 as per the concept what we have seen. So here we need to calculate the position of the center of mass, means we have to go with the concept XCM. XCM is equals to m1 x1 plus m2 x2 by m1 plus m2. So if we solve this, what we are going to see, let us take care. This is what m1 is 1 into x1 is -1 plus m2 is 2, x2 you can see x2 is 2 by m1 plus m2, 1 plus 2, 1 plus 2. So what we are getting, see here, this is -1 plus 4 by 3. Therefore we can write this is -4 plus -1 plus 4 by 3. So 4 minus 1, it is 3 by 3. So answer is 1. We are getting answer as 1 for x coordinate. Now let us move for the y coordinate. Y coordinate is what? m1 y1 plus m2 y2 by m1 plus m2. So if you move with this, so what is m1 and y1? You can see from here, that is what I can say, m1 y1, m1 is 1, y1 is 2 plus m2 is 2 and y2 is 4. So 2 into 4 divided by 1 plus 2. So this is how much? 2 plus 8. So I'll write that 2 plus 8 by 3, that is 10 by 3. Now how to write or how to mention the coordinates of the center of mass xcm comma ycm, that already I have given you. That means center of mass we can write it as 1 comma 10 by 3. So therefore center of mass is equal to 1 comma 10 by 3. I hope you have understood the problem how we have solved. Now students, just now we have seen a problem on concept of the center of mass for 2 dimensions. Now let us move for another problem. The problem is on the board, you can see. The problem here it is 2 blocks are there. Try to understand. 2 blocks of masses 10 kg and 30 kg are placed on the x-axis. They are placed on the x-axis. So therefore I clearly understand here that this we are solving for only 1 dimension. So 10 kg and 30 kg are kept on the x-axis. The first block is moved on the axis by a distance of 2 centimeter right. First block को हम क्या करें, 10 kg मास को 2 centimeter right की तरफ हम shift करें बेटा, move करें हैं. By what distance should the second mass be moved to keep the position of the center of mass unchanged? यहाँ पे हमारे को क्या होना है बेटा? Try to understand. It's a very good question with a good example here. I'm keeping 2 objects, 2 blocks. So this is y-axis, this is x-axis. So what I'm doing here is I'm keeping 1 block here, and this block, it's clearly mentioned, this is 10 kg block, 10 kg block, and another block is there just here, somewhere here, it is 30. This is 30 kg block. Both are kept on the x-axis. Both are kept on the x-axis. Next, what we are doing, the first block is moved on the axis by a distance of 2 centimeter. मतलब इस ब्लॉक को बेटा यहाँ पे मैं शिफ्ट कर रहा हूँ. कितना डिस्टेंस हम यहाँ पे लेके गए? 2 centimeter लेके गए. Change in the position for the first block is 2 centimeter. तो जैसा ही हम इसको इधर शिफ्ट करते हैं, तो where will be the center of mass? Center of mass will get shifted somewhat here. ट्राई टू अंडरस्टैंड. इस दोनों ब्लॉक्स इस तरह रहेंगे ना बेटे, यहीं पे है. जस्ट इमेजिन दोनों ब्लॉक्स यहां पर हैं, ठीक है, यहां पे है. तो वेयर इज द सेंटर ऑफ मास? समवेयर हियर द सेंटर ऑफ मास. आई एम जस्ट इमेजिनिंग, आई एम जस्ट सेइंग यू, सेंटर ऑफ मास इधर है. अब मैं इस ब्लॉक को थोड़ा सा मैं इधर शिफ्ट करता हूं, तो विल द सेंटर ऑफ मास विल रिमेन हियर? नहीं. ये क्या होने वाला है? ये भी तो इधर शिफ्ट हो जाएगा. जैसा ही हम ये ब्लॉक को इधर शिफ्ट करते हैं, सेंटर ऑफ मास विल गेट शिफ्टेड. But as per the question, we don't want any change in the position of the center of mass. So what we are doing is, जैसा ही हम इसको इधर हटाएं, तो पोजीशन ऑफ सेंटर ऑफ मास इधर हटेगा. तो हम क्या कर रहे हैं, इस ब्लॉक को भी थोड़ा सा हम इधर हटा देंगे, सो दैट द सेंटर ऑफ मास शुड नॉट गेट चेंज. जहां पे सेंटर ऑफ मास है वहीं पे रहना है, और दोनों ब्लॉक्स को हमारे को मूव करना है. सेंटर ऑफ मास शुड नॉट गेट चेंज. इट्स ए वेरी सिंपल कॉन्सेप्ट इफ यू अंडरस्टैंड. सी यहां पे दे दिया गया बेटा डेल्टा x1, इट इज नॉट x1, डेल्टा x1 कितना चेंज करे, कितना मूव करे, 2 सेंटीमीटर, 2 सेंटीमीटर. So this we need to move this side, right? Delta x2 we need to calculate, and this is how much, that is our question. Now pay attention. I know the formula for the position of the center of mass. It is m1 x1 plus m2 x2 by m1 plus m2. I hope the formula you remember. Now this is the coordinates or the position of the center of mass. If suppose the same formula I want to modify for the change in the positions of center of mass, how I can go with this? Let us see. If I take a change m1, change in the position of the first object, suppose it is delta x1 plus m2, इसमें कितना चेंज लाना है बेटा इधर हमारे को, डेल्टा x2 by m1 plus m2. So when you are changing the two particles as per the concept of the center of mass, 100% the position of the center of mass will get changed. तो कितना चेंज हुआ, डेल्टा xcm. ये हम क्या करें बेटा, इसको मॉडिफाई करें. अभी हम कंडीशन नहीं लगाए, हम वी हैव नॉट अप्लाइड द कंडीशन एज पर आवर क्वेश्चन. Now whenever there is a change in the position of x1 as delta x1, x2 as delta x2, then 100% there will be a change in the position of the center of mass, that is from xcm we are getting a change, that is delta xcm. अब आइए क्वेश्चन पर. अब हम को देखते हैं क्वेश्चन. क्वेश्चन क्या बता रहा है बेटा, what we are saying, by what distance should the second mass be moved to keep the position of the center of mass unchanged. मतलब सेंटर ऑफ मास चेंज नहीं होना, सेंटर ऑफ मास चेंज नहीं होना, दैट मींस डेल्टा एक्सियम मस्ट बी जीरो. ये चेंज नहीं होना तो जीरो होना बेटा. तो व्हाट आई डू, आई टेक दिस एज जीरो इज इक्वल्स टू m1. हाउ मच इज m1, 10, डेल्टा x1 it is 22 plus m2 it is 30, and we don't know delta x2, we need to calculate by m1 plus m2, 10 plus 30. Now 10 plus 30 is how much, 40. 40 if you cross multiply with 0, how much it is, 0 only, that is 0. So overall what I am getting, 20 plus 30 x2, 20 plus 30 x delta x2, not x2, it is delta x2, is equals to 0. So 30 delta x2 is equal to minus 20. So what I do here is I 0 get cancelled, that is you can say 10 से हम कैंसिल कर रहे हैं 2 टाइम्स और यहाँ पे हम 3 टाइम्स. सो ओवरऑल व्हाट आई एम गेटिंग, डेल्टा x2 is equals to minus 2 by 3 सेंटीमीटर. दैट मीन्स आपको क्या करना है, अगर इसको हम 2 सेंटीमीटर हटाते हैं तो इसको कितना हटाना है, how much we have to move this, try to see, it is what, minus 2 by 3, ये साइड हटाना है. अब रही बात, why we are getting this negative sign, what is the reason of this negative sign? The reason of this negative sign is ये right को move हुआ ना बेटा, ये right को move हुआ, so that's why we have taken plus plus 2 as per the question. तो हमारे को किधर हटाना है, इसको लेफ्ट की तरफ हटाना है. तो लेफ्ट जो अपोजिट डायरेक्शन है that is indicated by minus. तो कितना मूवमेंट आना है ब्लॉक में, 2 by 3 सेंटीमीटर. और किस साइड हटना है, दिस साइड हटना है. I hope the concept is clear, the question is clear along with the solution. Now students, we move to another concept of center of mass, that is a position vector of the center of mass. So far we have seen how to calculate the position of the center of mass in 1D, 2D and 3D. Now we are going to see how to calculate the position vector of center of mass. Vector, you know, it has both magnitude as well as direction, and it obeys the laws of vector addition. So that we are going to discuss. So give the heading position vector of center of mass. Position vector of center of mass. The new concept, position vector of center of mass. So for this, let us take an example here. What I consider, this is x axis, this is y axis, and of course you can consider the z axis also. It depending आप लेना चाह रहे या नहीं लेना चाह रहे आपके ऊपर है बेटा. The concept will be the same. Okay, you need not to worry. This is origin. So what I consider here is, I consider a particle of mass m1. देखिए बेटा अच्छे से देखना है, a particle of mass m1 whose position vector, this is a particle of mass m1 whose position vector is r1. Position vector is how much here? r1. Next we go for another particle here of mass m2 and the position vector is r2. These are the position vectors. This is the vector. That's why I'm indicating by the direction. Particular direction is also there. Next, I'm keeping another particle of mass m2, whose position vector is r2. Let us take another also, third one bhi lete hain. So here I'm keeping one more particle of mass m3 whose position vector is r3. So under this situation, how to calculate the position of the center of mass? Of course, the position vector of the center of mass. तो कैसा हम इसको हम कैलकुलेट करते हैं? इट्स वेरी सिंपल, बिकॉज इट इज डिपेंडेंट ऑन द प्रीवियस कॉन्सेप्ट. सो डायरेक्टली हम यहाँ पे लिखते हैं, देखिए अब आप RCM, the position vector of the center of mass, m1 r1, m2 r2 plus m3 r3. Bar, why I'm writing? Because all they are vectors. ठीक है, divided by m1 plus m2 plus m3. Here you need to be careful whether two particles are given, three particles are given, four particles are given. If two particles are given, you can write directly m1 r1 plus m2 r2 by m1 plus m2. Four particles are given, just you have to take care of one more term, that is m3 m4 r4. यहाँ पे हम एक और ऐड करेंगे बेटा, वो रहेगा m4. Depending on the number of particles, you need to frame the formula. We don't have any exact formula. आप depending on the number of particles, आप अपने हिसाब से आप formula बनाएंगे और उसमें आप substitute करेंगे. I hope it is clear. Now, based on the same concept, we have one problem. So first, you copy this one. Let us solve one problem based on the position vector of center of mass. The problem is on the board here. See, three particles are given. M1 as 1 kg, M2 you can see it is 2 kg, M3 is 4 kg. And here position vectors are also mentioned, R1, R2 and R3 respectively. Find the position vector of the center of mass. So it's a very simple concept, that what we have already seen. So what I do here is, I take here directly position of the center of mass as m1 r1, m2 r2 plus m3 r3. Why I'm taking till 3? Because 3 masses are given. So what I do, divided by m1 plus m2 plus m3. Now students, what I take, this is m1. What is m1 here? m1 देखिए students, how much it is m1? m1 is just 1 kg. So I take here 1. And what is the vector here? Vector for r1, I plus 4j plus k. I plus 4j plus k plus m2. m2 is 2 kg into, what is the position vector? You can see the position vector here, I plus j plus k. So here I'll take it as I plus j plus k. Plus third particle is of mass 4 kg and its position vector is 2i plus j plus 2k, divided by m1 plus m2 plus m3, 1 plus 2 plus 4. So this you can just multiply it. This is how much? I plus 4j plus k plus 2i plus 2j plus 2k plus, if you multiply this, 8i plus 4j plus 8k, divided by, it is 7. So I plus 2i, 3i, 3i plus 8i, that is 11i. So I am taking it is 11i. 4j plus 2j, 6j plus 4j, 10j. K plus 2k, it is 3k. 3k plus 8k, it's 11k by 7. So this is the position vector for the center of mass. See students, you have to be very careful while studying the concept. Don't just mug up the concept. Try to understand the concept. If your concept is clear, then you can do any problem what is getting asked. So I hope you have understood the question, how the question, what is the question given, and how we have solved the question, that is our solution for this question. Hope it is clear.